Following is a video for 12.8 notes, and this is the title of the section is called Congruent and Similar Solids. So we're going to look at the attributes of those. So the first thing I want to talk about real quick is similar solids. Okay, so similar solids. Okay, and we know if we have a similar solid, if the corresponding measurements are proportional. Okay? And so what I would say here is that my height here of this cone, if I took the height sub 1 and divided that by height sub 2, this would be equivalent to me saying r sub 1 divided by r sub 2. Okay, so if I take the radius of this and divide it by the radius of that, it will be equivalent to this height divided by this height. Okay, and this is just kind of very similar to what we did when we had similar triangles and similar polygons. Okay, the sides are proportional. Okay, and we can set up this relationship. Now we have another one where we have congruent solids. Okay, congruent solids. And what we would do here is we would do the same thing, and that just means that your corresponding measurements, so your corresponding measurements are congruent. All right, so if I took h sub 1, this height, and divided it by this height, then that would equal the this slant height, L sub 1, divided by this slant height, L sub 2. But if I divided those, they would not only equal each other, but they would also equal 1 because they are the same. Okay, so if I take something and divide it by another thing, and if those are the same measurements, then I'll just get 1. Okay, so the one thing I do want to talk about on here, and you'll need to write this kind of on the right side, I want to talk about similar solids. Similar solids. Okay. Now we have a couple things that we can talk about. We can talk about the ratio of side lengths, ratio of sides, and that would be just a simple ratio A over B. Okay. If we talk about the ratio of surface area, then that's going to give us A squared over B squared, which is the quantity A over B, and I square it. Now remember that the ratio of side lengths, that's just a single measurement. Okay, we raise that to the first power and to the first power. If we're talking about area, that's a square unit. Okay, so we can if we have similar solids, we can find the surface area, and we take that ratio and we square it. Okay, but if we take the ratio of volume, okay, which is a cubic measurement, that would be A over B, A cubed over B cubed, which would be equivalent to me saying just A over B, that quantity cubed. Okay, and I'll show you how this works here in a second, but we want to use this notion that if we're talking about the ratio of surface areas, then we take the ratio of sides that we can find by the side lengths, and then we can just square it. Okay, so let's put this into practice a little bit. And number 1, it tells us determine whether each pair of solids is similar, congruent, or neither. If the solids are similar, then state the scale factor. So what I want to do is I want to look at the corresponding sides. So I'm going to look at 2 centimeters here and 6 centimeters here. I'm going to divide those. I'm going to go 2 over 6. Okay, and I want to determine, is that equal to this height divided by that height? So I'm going to take 4 and divide it by 12. All right, so I take 4 and divide it by 12. Now, on this one, I'm going to do the last one, is 3 over 9 equivalent to all these? Okay, and so what we can find out is that, yes, in fact, these are equivalent. You could cross-multiply and determine if they are proportional. But I know that all of these simplify to 1/3. Okay, so this is what we would call a similar solid. Okay, not solid, solid. All right, so my scale factor, all right, would be 1 over 3. We could also write that as 1, 2, 3. Okay, 1:3. All right, let's take a look at number 2. All right, so let's see if these are similar. Now my radius here is equal to 5, not 10. Radius is equal to 5 meters. Here my diameter is equal to 10 meters. Now if I get my diameter, I know my radius is just half of that. So if I divide that by 2, I get that my radius is 5 meters. Okay. So if I take the radius here, which is 5 meters, and divide it by the radius over here, which is 5 meters, then I get that we have a value of 1. 5 divided by 5 gives me 1. And so I know that these are congruent. Okay, congruent solids. All right, they're the same size. Okay. All right, take a look at number 3. If two similar pyramids have heights of 4 inches and 7 inches, what is the ratio of the volume of the small pyramid to the volume of the large pyramid? So I know I have two similar pyramids, okay? Heights of 4 and 7, okay? So I have a scale factor, okay, which is the same as the ratio of their side lengths, all right? And that would be 4 divided by 7, okay? So then if I wanted to find the ratio of their volume, then I would simply just take 4 over 7, and I would cube the whole thing. Now, when I cube a fraction, that means I'm going to take the numerator cubed and divide it by the denominator cubed. All right, and if I take 4 cubed, and that's 4 times 4 times 4, then I'm going to get 64, and then if I take 7 cubed in my calculator, then I get 343. And this is my answer. Okay, this is the ratio of our volume. I take my ratio of side lengths and I cube it, and that's what I get. All right, let's take a look at number 4. Now, number 4 is a word problem. It says 2 stock pots are similar cylinders. Okay, so I'm just going to draw a quick cylinder here. It's usually helpful to draw a picture. The smaller stock pot has a height of 10 inches, okay, and a radius of 2.5 inches. So this is my radius. R is equal to 2.5 inches, okay, and my height is equal to 10 inches. The larger stock pot has a height of 16. So I'm going to come down here. I'm going to draw a bigger one. Pardon my drawing. Doesn't look very good, but you get the idea. My height is equal to 16 inches, and I don't know what my radius is. Okay, but I'm just going to leave it here. I don't know what my radius is. Okay, and it says, now what is the volume of this? So what's my volume? Okay, now what I can do, this is kind of a tricky problem, all right? I could take, let me find my scale factor. Okay, I know that these are similar. It tells me that they're similar. So I have a scale factor. And I'm going to take this height divided by this height. I'm going to take 10 over 16, all right, which is equivalent to me, if I take both of those and divide it by 2, I get 5/8. Okay, so that's my scale factor. Okay, this is also the ratio of my sides. Okay, now I know this, that if I take the ratio of sides, 5/8, and if I cube this thing, then that's going to give me the ratio of volumes, okay? And that's going to be 5 cubed divided by 8 cubed. And if I put those in the calculator, then I get 125 divided by 512. Okay, that's just 5 cubed is 125, 8 cubed is 512. This is the ratio of volumes. Okay, so I want to use this to find the volume of this. I don't know what the volume of this is, but I do need to have the volume of my smaller one. Now my volume of the smaller one is going to be pi times 2.5 squared times my height, which is 10. Now what I'm going to do, I'm going to leave it like this. I'm going to take 2.5 squared is 6.25, and then multiply that by 10. This gives me 62.5 times pi. All right, and that's my volume of my smaller one. So if I set up a new proportion here, if I say 125 divided by 512, then that's equal to the volume of my smaller one, which is 62.5 times pi, being divided by the volume of my big cylinder. So I could cross multiply and divide and solve for the volume of the big. All right, and if I cross multiply and divide that, I actually end up getting a volume of 804.2, and that's inches cubed. Okay, so if I know that something is similar and I know the volume of one, I can actually calculate the volume of the other, provided I'm given a side length. So I have to start off with my scale factor, okay, cube everything, get the ratio of volume, and then set up a proportion with that ratio of volumes with the other volume, and I'm able to solve for the other volume. Okay, I hope this helps. Please get started on your 12.8 homework, and I hope you enjoyed this video as much fun as I had making it.